Here, this initial value problem looks a little bit different because we're not given f prime of x, we're given f double prime of x. So we're given the second derivative, a point that goes through the first derivative, and a point that goes through the original function. So we're just kind of starting lower down the totem pole. We're starting down at f double prime. We're going to have to work our way back to the original function by going first through f prime, back to f. So we basically have to do two IVPs, initial value problem, twice. We'll do it once to get to f prime and a second time to get back to f. Just like when we took the derivative, we had to take the first derivative and then take the second derivative. There wasn't a shortcut to do two derivatives at once. There's no shortcut to do two antiderivatives at once. So that's all right. We're still going to follow our same 3 steps. We're just going to do them twice. So for our first time through, we're going to go from f double prime of x to f prime of x, taking the antiderivative once. So f prime of x is going to be the antiderivative of f double prime, which is given to be 25x to the 4th minus 2x plus 4. And we have to take the integral symbol, so we're going to write dx. So now I'm ready to integrate. I'm going to do 25 over 4 plus 1 is 5. So maybe this first time I'll write it out, but normally I would simplify. 4 plus 1 is 5. So I would really write 25 over 5 as just being 5, but we'll fix that in a second. So 25 over 5, x to the 5, minus, same thing with this, I would normally simplify fractions. 1 plus 1 is 2, so we're going to get 2 over 2, x to the 2. And the antiderivative of 4 is 4x plus c. So then on our second step, I'm going to write that antiderivative a little bit nicer. Our second step is to plug in what point we're given on f prime, which is going to be this f prime of 1 is supposed to be negative 4. So I'm going to plug in f prime of 1. And 25 over 5 is 5 times 1 to the 5th. Minus 2 over 2 is just 1. X squared, so 1 squared, plus 4 times 1. So all I did there was simplify the 25 over 5 as being 5, and minus 2 over 2x squared is just really minus an x squared, plus 4 times my x is 1, plus c has to equal negative 4, according to this setup. So remember PEMDAS exponents before multiplying, so 1 to the 5th is 1. Times 5 is just going to be 5, minus a 1 squared is 1, plus 4 times 1 is 4, plus c is supposed to equal negative 4. So we have 5 plus 4 is 9, minus 1 is 8, plus c is negative 4. So then subtract 8 from both sides. C must be negative 12. So then my third step here is to write out the function. So f prime of x must have really been 5x to the 5th minus x squared plus 4x minus 12. There's my first initial value problem. We just went from the second derivative back to the first derivative. And now I'm going to repeat those same steps to get from the first derivative to the original function. So that first step, f of x is going to be the antiderivative of f prime. So 5x to the 5th minus x squared plus 4x minus 12 dx. I'm going to shift this down a tiny bit. So we're going to take the antiderivative of the whole function here. And the antiderivative of f prime is called f of x. So now we're on the original function. I'm going to take the antiderivative. So my power is 5 plus 1 is 6. X to the 6 minus 2 plus 1 is 3. X to the 3 plus 4 over 2 x to the 2. I'm just going to simplify that. 4 divided by 2 is just 2x squared, which makes sense because the derivative of 2x squared is 4x. So the antiderivative of 4x is 2x squared minus antiderivative of 12 is 12x plus c. Now we're going to do our second step. We're going to plug in the other point. F of 1 is supposed to equal 2. So we're going to use that to solve for what c is. So I'm going to plug in f of 1, which is going to be 5 6 times 1 to the 6 minus 1/3 times 1 to the 3rd plus 2 times 1 squared minus 12 times 1 plus c is supposed to equal 2. So now the last one, I did it in my head. I said, hey, let's think about our whole numbers first, which would be 2 and negative 12 on that left side, and then we would leave the fractions on the other side. Maybe for this one, I'm just going to plug right into my calculator and see what the whole constant is on the left side there, because either option is fine, using your calculator or just plugging in, and I would move just the constants first and then focus on the fractions. But if we combine everything on that left side, 5 6 times 1 to the 6 minus 1/3 times 1 to the 3rd plus 2 times 1 squared minus 12 times 1, and just plug it into our calculator, we get negative 9.5, which is a nice decimal that terminates. So we could leave it as a decimal. If you wanted to make it a fraction, that is totally fine too. But you don't have to make it a fraction unless it keeps going. If it was 9.3 repeating, I would make it a fraction. So that we had an exact answer. But this is just a nice decimal, negative 9.5. So I'm going to add that to the other side. So you get c by itself would be 11.5. Or if you want to write that as a fraction, that's fine. It would just be 23/2. So my third and final step with this, kind of run out of space here, would be f of x is 5 6 x to the 6 minus 1/3 x to the 3rd plus 2x squared minus 12x plus 11.5. There's our final function. So if you're working from f double prime all the way back to f, it is the same 3 steps. You just have to do it twice instead of once.